Exercise 2.2. Calculate the line current IL for each of the following circuits. So that's the first exercise. So here they recommend us to use the superposition laws theorem. So they want us to determine the current IL. So IL represents the current flowing in that resistor. So here we realize that we have two voltage sources. So the superposition theorem consists of closing the first source of voltage and considering only the second source of voltage, and afterwards we can calculate IL with only that voltage. And in the second step we are going to close that source, and then we are going to consider that one, and then we calculate the second current flowing in this resistor. So at the end we are going to add them. So we add the current that we found while considering this voltage and the current that we found by considering this voltage. So in the first step we are going to close this voltage here. So if we close this voltage, the diagram will be transformed to the following. So here we have 8 ohm, 25 ohm, and that is IL. So as we can see, there is not 36 volts because we just close or just short circuit or close the second source of voltage. So the resistance here is 9 ohm, and here we have 48 volts. So now afterwards we are going to compute the value of IL, so the current flowing in 25 ohm, while considering this voltage only. So here we can say that these two resistors are in parallel. So these two resistors are in parallel, and that one is in series with these two that are in parallel. So the total resistance, so we'll first need to determine the total current. The total current is that one, which is the same as that one. Or at that point here, the current is split into two branches. So we have the first current flowing in 25 ohm resistor, and the second current which flows through a 8 ohm resistance. So we know that to find the total current we need to use that voltage. So we are going to say total voltage divided by the equivalent resistance, or we call it R equivalent. So R equivalent is the total resistance. So we are going to consider the resistance that are in parallel. So we have these two resistance that are in parallel, and then we have one resistor which is in series with these two. So here we are going to compute the equivalent resistance. So the equivalent resistance is equal to, we realize that we have a resistance of 9 ohm, which is in series with these two that are in parallel. So we have 25, which is in parallel with 8. So now we need to compute this expression here. So we know that if we have two resistors that are in parallel, the total resistance will be the product of these two and then divided by the addition of the same resistance. So here we are going to replace all this by 25 multiplied by 8 divided by 25 plus 8. So we get the equivalent resistance. So the equivalent, if we use the calculator, the equivalent resistance value is equal to, so the equivalent resistance is equal to 15.06 ohm. So that is the equivalent resistance. So we have, how did I get this expression? Because these two resistance, so we have these two resistance that are in parallel. So we can find the equivalent resistance of these two, which is that. So if we multiply, since we only have two resistance, then we can say that the equivalent resistance will be the product of the resistance divided by the sum of the resistance. So this is what we did here. But since these two become 9 ohm and the equivalent resistance of these two resistors are in series, so I'm going to add them. So that's why we have 9 plus that one. So now to calculate the total current. So the total current is given by the voltage divided by the equivalent resistance. So we have the voltage which is 48. We divide by 15.06. So we get 3.187 amp. So that is the total current. IT is not the same as IL. So IL is the current flowing in 25 ohm, but the total current here is the total of the current flowing in this resistor and that one. So now we can determine, if we know that if we have two resistors that are connected in parallel, and we also know the total current crossing the whole branch, so the whole branch, so we can determine the current in each resistor. So I'm going to say IL is equal to, I'm gonna write down the total current. So I have the total current, which is 3.187 multiplied by, so we have the sum of, at the bottom we are going to use the sum of this resistance. So we have 25 plus 8, because that represents the current divisor. So to calculate the current, that's IT represents the total current, so that is why it is repeated here. So now to calculate the current in each branch, I will first copy the total current, and then I'm gonna add the sum of the resistance. I put them on the bottom, And then on top, as I'm calculating the current in 25, I won't use the 25 ohm resistor, but I'm gonna use 8 ohm resistor. I always use the opposite. So I'm gonna put 8 ohm here. If I was calculating the current in 8 ohm, then I'm gonna use 25. I'm gonna have 25 on top, but the denominator will still be the same, 25 plus 8. So I use 8 ohm because I'm calculating the currents in 25 ohm, not in 8 ohm. So that's gonna give me so I get 0.7726 amp. So that is IL. I haven't yet finished. So until now, these are all these steps are related to the main step. The main step is when I close this circuit and I only consider when I close this source of voltage and I only consider that one. So here I'm gonna say, so we have the step 1, which consists of short circuiting the second source of voltage. So in other words, I'm gonna close that source of voltage. So I will just put a 0 ohm conductor to signify that there is not any source of voltage. So now in the second step, I'm gonna close this source of voltage, and then I will now consider that one. Okay, let's go to the second step. So that is not the current IL. I'm gonna call it IL1, and I'm gonna call that one as I total 1, because I'm gonna also have I total 2 if I consider this 36 volts and then I close that one. So that's gonna be in step 2. So now we are in step 2. So the step 2 consists of closing this voltage source and considering that one. So here I'm gonna say we're going to short circuit the 48 sources the 48 source of voltage. So in other words, we are going to put a 0 ohm conductor here, so the circuit will transform to the following. So we have 9 ohm. So here there is not a source of voltage, so we just close. So this is that resistance here, and then we have a source of voltage on the right, which is the value is 36 volts, and that resistance here is 8 ohm. So here we have 25 ohm and then we have 9 volts, which is already given. So now we are going to have the total currents here, because we have a supply voltage. So that current is split into 2 branches. So we have the first current that flows through a 9 ohm resistor, and then we have the second current, which is called IL. So now we need to determine IL, but before we determine IL, we're gonna need to determine the total current. So to determine the total current, we're gonna need this voltage and the equivalent resistance. So I'm gonna call that total voltage. So I'm going to say the total current, so I'm gonna call it the total current 2, because we are working with the second source of voltage. So I'm gonna call it I total 2, and that is V total 2, and then that is the load current 2. So to get the total current, we are going to use this formula here. So we have the supply voltage divided by the equivalent resistance. So now to calculate the equivalent resistance, we are going to apply the same logic that we apply in step 1. So realize that these two resistors are in parallel. So the whole branch here is connected in series with that resistor. So I'm gonna say that as these two resistors are in parallel, so the equivalent resistance of these two will be 9, which is in parallel with 25. So all this represents the whole set. So now the whole set is in series with 8 ohm resistor. So since they are in series, then I'm gonna add 8 ohm to the set. So now I'm gonna simplify this. So that's gonna give, so the equivalent resistance of these two, since they are in series, I will first multiply these two. So I have 25 and 8 and 9, and then at the bottom I will add them. So I have 25 and 9. So just repeat them. So we have 25 and 9. So on top we multiply, and then at the bottom we divide, and then we divide, and we add that 8. So that is this part here is equivalent to that one. So now I just need to work out with the calculator. So I'm gonna have the value of the total resistance, which is equal to we get the equivalent resistance, which is equal to 6.6176 ohm. So now once I have the equivalent resistance, I will now be able to determine the total current. Because to get the total current, we are going to use this formula. We have the supply voltage, which is 36, and then we have the equivalent resistance, which is 6.617. So if I use the calculator, to compute this, I'm gonna get 36 divided by 6.617. So I get 5. So since we are calculating the current, so the unit supposed to be amp. So that is the total current coming. So now if we know the total current, because that total current will pass through the will cross this set of resistors. So in other words, there is one part of current that's gonna flow through 9 ohm resistor, and another current is gonna flow through the 25 ohm resistor. So that represents the current divisors. So to find the currents IL2, the load current in this resistance, so we are going to say that IL2 is equal to, so we first copy the total current, which is 5.44, and then here we realize that we have these two resistors that are in parallel. So we are going to add these two resistors at the bottom. So we have 9 plus 25, and then on top we are going to use the opposite of, we are going to use the resistance that is opposite to the one where the one that is crossed by the current that you are supposed to find. Since we are finding IL2, so in other words, we need to find the current passing through this resistance. But instead of using this resistance, we are going to use that one. So we are going to use that one on top. So I'm going to write 9 instead of 25. So it's the same procedure that we did in step 1. So we get, so if we work out this, we are going to get so we get 1.44 amp. So that is the load current in this resistor when this voltage source here is short circuited. So then the last step will be to add the two currents. So if the first current was determined from the first step, so he finds IL1, so the load current in this resistance. So we have considered this voltage and not that one, and in the second step we have considered this voltage, and then we close that one to get the current IL2. So now the last step will be to add the two currents. So we have step 3. So we need to add the first load current and the second load current. So that means the first load current was determined in step 1 and the second load current was determined in step 2. So if I go to step 1, the current is 0.7726. So I'm gonna say IL is equal to IL1 plus IL2. So I have IL1, which is 0.7726, and then I have IL2. So it's the current that I've determined in the second step. So we get 1.44. So that represents IL2. There is a typical mistake in step 2. So the problem is here. So if I compute this, I won't get 6.6176, but I'm gonna get, so we have 9 multiplied by 25 divided by 9 plus 25, and then plus 8. So that should be replaced by 14.617. So I'll just remove it, and then I say the equivalent resistance will be equal to 14.618 ohm. So the whole thing will change. So I will change this, and here, but this one will stay the same, this part here, because we are using the same resistance. So as I have the equivalent resistance, to get the current, I'll just substitute it here. So that's gonna be the total current, that one. So I have 36 divided by 14.618. So I get 2.463 amp. So I have the current, the total current. Then to get the load currents here, I'll just replace it. So if I compute, I'm gonna end up to so I have 2.463 multiplied by 9 divided by 9 plus 25. So I get 0.6717 amp. So that is IL2, the load current in 25 ohm. So if I consider this source and I close that one, so now we go to step 3. I just need to replace the value of IL2 with the new one. So the new one is 0.671, and I will end up with the total, which is equal to, so if I add that one, I'm gonna get so I get a value which is close to the one that they found. Yeah, that's it.